Today we're going to be talking about properties of a triangle, understanding the different types of triangles that there are, and also how to calculate angles in triangles that also involve straight lines. So firstly, we're going to look at different types of triangles. So here you can see that there are 4 types of triangles. They're all different in some ways, but they are still triangles. The reason for it is because in the name triangles, tri means 3. So these shapes all have 3 sides. So the first one we have here is an equilateral triangle. Now, what you're going to see here in the image is you have an equilateral triangle and you have these little dashes on the lines. Now, hopefully you'll know that what these little dashes means is that these 3 sides are all equal. So, for example, if this one was 4 centimetres, this one will also be 4 centimetres, and so will this one. And similarly, you'll notice that all the 3 angles are also in the same shade. So that means that all 3 angles are also equal. So the properties of this triangle is that all 3 sides are equal and all 3 angles are equal. So that's an equilateral triangle, kind of says it in the name, equal. Our second triangle, we've got an isosceles triangle. And very similar to the equilateral, you'll see that it also has a pair of dashes, but only on 2 sides. And that will mean that these 2 sides here are equal in length. Very similarly, the 2 angles at the bottom, so that go next to your straight lines, are also equal. So properties of this triangle is it has 2 equal sides and 2 equal angles. A scalene, well, you'll notice that a scalene has no properties that we can identify on the triangle itself. That means it has no equal sides and no equal angles. So each angle will be a different degree, and so will each side. And then finally, a right angle. A right angle is quite obvious. Any triangle that has a 90-degree angle is called a right angle, no matter the length of the sides, whether they're equal or not. Any triangle that has a 90-degree angle in it is called a right angle triangle. And obviously it has a 190-degree angle, as I just said. So these are the 4 types of triangles that are always going to be coming up. Mostly the scalene when we're calculating angles, but also the isosceles because of those pairs that are equal, that pair of angles. So a couple of facts about angles in a triangle. The angles in a triangle add up to 180 degrees. So all 3 angles inside your triangle will always add up to 180 degrees. So the diagram I have here, I have angle A, B and C. All 3 angles inside our triangle, and an equation to write it is that A plus B plus C is equal to 180. Now, when we're finding missing angles, which we'll do a couple of examples in a bit, we're just going to rearrange this formula. So what we're going to do is we're going to 180, take away whatever angles they've given us, and then find our missing angle. But that will come later on. For now, just remember that all 3 angles in a triangle, when added together, will and must add up to 180 degrees. If they don't, it means that something is wrong. So angles on a straight line, around a point and in a triangle. So here we're going to look at angles on straight lines and then involving triangles and how we can calculate those missing angles. So I've got 4 types of angles here. First one, we've kind of already discussed this when we were talking about our right angle triangle. Any angle that's 90 degrees is a right angle. Now we've come along to this side. An angle that is less than 90 degrees is called an acute angle, so a small angle. Use the word acute. Acute usually refers to minute, so a smaller angle is an acute angle. Then we'll go down here to this one's quite a large angle. That's called an obtuse, okay? So another way to refer it, obtuse kind of sounds like a big thing, so it's a larger angle, bigger than 90 degrees. And then finally, an angle that's quite large and bigger than 180 degrees is called a reflex angle. The way that sometimes people might note this down is that a right angle is always going to be equal to 90 degrees. An acute angle is always going to be less than 90 degrees. A reflex angle is always going to be an obtuse angle is always going to be more than 90 degrees. And then a reflex angle is always going to be more than 180 degrees. Okay, you'll notice that it's quite a large angle. Okay, angles around a point. So it's a 360 turn. So a full turn is equal to 360 degrees. So if we were calculating each individual angle and added all 4 of these angles up, as you can see it's split into 4, but it can be split into 5, split into 2. But if you were to add an angle, all of the angles around a point, they will all add up to 360 degrees. So using this diagram, if we were to do A plus B plus C plus D, it would equal to 360. If our full turn was only A, B and C, then if we added A, B, and C, it would also equal 360. But in this diagram, we've split around our point into 4 segments. But regardless, no matter how many segments you have, when you add all of them together, you should always end up with 360 degrees. Angles on a straight line. So angles on a straight line, again, your straight line is equal to a half term, which adds up to 180 degrees. So your half turn, so half of a full turn, so if a full turn is 360, that means a half turn is equal to 180. Again, this is just an example. It's split into 2 segments. However, it could be split into more, but in this case, it's only split into 2. So if we were to do A plus B, it would equal to 180 degrees. No matter what you do, it will always equal to 180 degrees, any angle on a straight line. And these are going to be, this especially on a straight line is going to be very, very useful when we then go to find missing angles on triangles. So angles in a triangle, we've already referred to this. They all add up to 180. And finally, vertical opposite angles. So opposite angles are equal. So in this instance, you'll notice that the shades of the colours are the same. So the grey angles are equal. So A is equal to C. And then the angles D and B have also got the same shade. So the blue shade, these are equal. So any opposite angle is equal. It's really important that you note down these explanations, just these quick sentences, and sketch a quick diagram so that you can have them for later questions. Now let's go through some examples together on how to find missing angles using triangles. So we're given a triangle here and we're trying to find the value of x. Now hopefully we'll remember that the angles in a triangle, let me just rub that out. In a triangle equal 180 degrees when all added up. So we're given 2 angles. We're given 80 degrees and we're also given 60 degrees. There's 2 ways you can calculate this. You can add your 2 given angles, which is 80 plus 60, and when you do 80 plus 60 you get a value of 140. So you know that these two angles added together give you 140, and you're trying to find x. So x is obviously going to be equal to 180, which is all 3 added together. Subtract the total of what you already have, which is 140, and that means that x is equal to 40 degrees. Another way you can do it, which is quite straightforward, is you know that a triangle adds up to 180 degrees. You're given 2 angles, so you're going to subtract 80, subtract 60, and you should get given an answer of 40 degrees. Okay, so moving on, just write that in, 40 degrees. So that x is equal to 40 degrees. Another example. Again, we're given a triangle and we're not told one of the angles in here, but we are told the other 2. So same thing, I find it quite easy if I add them together. So if I do 18 plus 25, I get a value of 43 degrees. So these 2 added together are 43 degrees. I know that all 3 added together give me 180. So I do 180, subtract 43, which will give me an answer of 137 degrees. Therefore, I know that x is equal to 137 degrees. As I'm going along with these examples, you do not have to copy all of them down, but copy out the necessary ones, the ones that you think it will be valued to have them written in your books. Another example. So here, it's not written, we're not told the value, but we should remember that when we have that little sort of square in a corner of a triangle, what this means here, it's a right angle, which equals to 90 degrees. Okay, so again, I know that one angle is 90 degrees, another angle is 27 degrees, so I'm going to do 90 plus 27, which gives me a value of 117 degrees. So that's these 2 added together, and I need to find the value of x. So I know that all 3 added together should give me 180, so I do 180, subtract my previous answer of 117, and I get a value of 63 degrees. So x is going to be equal to 63 degrees. Another example, so here you'll notice that hopefully from writing down the properties of your triangles, you'll see that this triangle is an isosceles triangle, and that means that these two angles here, angle A will go A, B and C. Angle A is equal to angle C because it's an isosceles triangle. These two angles down here are equal. Therefore, angle A is equal to 35 and angle C is equal to 35. And I'll also write it in here. So this one is also equal to 35 degrees. So now that I now know two of my angles, I just have to do 35 plus 35, which gives me an answer of 70 degrees. And then I do 180, which is a total of the triangle, subtract what I have, which is 70 degrees, which will give me a value of 110 degrees. Therefore, for this triangle, x is equal to 110 degrees. Another example, so very similar to the previous one, it's also an isosceles triangle. However, this time I'm trying to find one of the equal angles, so one of the pairs. So 24, I'm going to do 180 is equal, take away 24. When I do 180, take away 24, I get a value of 156 degrees. Now, 156 degrees is this angle plus this angle, and the reason for it is because those are both equal, and because they're both equal, all I have to do is do 156 divided by 2, which will give me a value of 78 degrees, and that means that both these angles are equal to 78 degrees. Even though I only need to find out one, which is this one down here, both of them are going to be equal, so x is equal to 78 degrees. Let's have a look at another one. So this one just looks different because it's upside down to how we normally draw a triangle, but it's the exact thing as our previous question. It's an isosceles triangle. That means that these two angles are equal. Okay, so first thing I'm going to do is I'm going to do 180, subtract the angle that I'm given, so 180, take away 38, which gives me a value of 142 degrees. I know that these two angles are equal, and because there's two of them, there's a pair, I'm going to do 142 divided by 2, which will give me an answer of 71. So x is equal to 71 degrees. Let's go with another example. So this example involves a straight line. So the first thing we have to do is find this angle here. Okay, I'm going to call this angle A. We're given one angle inside our triangle, but it's not enough to find x. So we need to find the angle in this corner first. And we're going to be able to find that because this is on a straight line. And hopefully, from previously knowing, a straight line is equal to 180 degrees. So to find A, we have to do 180 subtract 125. And 180 subtract 125 gives us a value of 55 degrees. So now I know that this angle here is equal to 55 degrees. And now I can find out the value of x because I can do 180 subtract these two angles, and I will now get that missing value. So I'm going to do 80 plus 55, which gives me an answer of 135 degrees, and then I do 180, which is what a triangle adds up to, subtract 135, and that gives me a value of 45 degrees. So angle x is equal to 45 degrees. Another example. So this time we're actually trying to find the angle outside of our triangle, so our obtuse angle. First thing you're going to do is you're going to find this angle here. And the reason for it is because we're given that outside one. And we should know that this straight line will equal to 180. So to find this angle here, we're going to do 180, subtract 111, and we get an answer of 69 degrees. So this angle here is now 69 degrees. Okay. Now that we know two of our angles, we can now find, change my color, we can now find this angle here. And the reason why is because we can do 180, subtract 74, and subtract 69 will give us this angle. So I'm going to do 69 plus 74, which gives me a value of 143, and then I'm going to do 180, take away 143, which gives me a value of 37 degrees. So this angle now here is 37 degrees. And then to find the value of x, which is our obtuse angle, okay, which is our obtuse angle, this angle outside here, I know that on a straight line, angle is equal to 180 degrees. So 180, subtract that inside angle of 37. 180 take away 37 gives me a value of 143 degrees. So x is equal to 143 degrees. In terms of simple triangles and straight lines, this is probably the hardest it's going to get, where you have to find one angle to then find the angles, all the angles inside your triangle to then find an angle outside. But take it one step at a time. Use the information that's given to you and see where you can start. So you're given that outside angle, so find the inside angle, okay, because it's on a straight line. So what would that angle there be? You can then find all angles inside a triangle, because you know they add up to 180 by subtracting the two that are given to you, and then finally finding that missing angle outside by using the rule of angles on a straight line. Let's go with this final example. So here we've got an isosceles triangle, and we're trying to find the value of x, so our angle, the only angle in our isosceles triangle that's not equal. So the first thing we can do is obviously find this angle here, and how we're going to find that is angles on a straight line equal to 180. So we're going to do 180 subtract 123. When we do 180 subtract 123, we get a value of 57 degrees. So I know that this angle here is equal to 57 degrees. Now hopefully you'll remember, angles in an isosceles triangle, the bottom angles here are equal. So this side of the triangle is also equal to 57 degrees. Now what I'm going to do is do 57 plus 57, where I get a value of 140. And then to find x, I'm going to do 180, subtract my total of my other two angles, which is 114, and I'm going to get a value of 66 degrees. So x is equal to 66 degrees. Task 1 is split onto two slides, and what I like to do is to draw a rough sketch of the question, okay, and then your answer, any workings out of how you do your answer, and then just a quick definition of the reason as to why you've got that answer. So the actual reason it started off for you. So the first question, we've got find the angle A when we've already been given 30, and angles on a straight line are equal to, and so on. So just a quick sentence of why the answer is what it is. So pause this video and have a go at these questions. Again, they are continued, so there are another, I think, 4 questions on the next slide, and then I'll be revealing the answers. Okay, moving on to the next part of this question. So same thing, pause the video and have a go at these questions. Remember to write out a little definition as to why the answer is what it is. Okay, now I'm going to put up the answers. Please make sure to red pen and mark your answers that you have done. And now task 2, I'd like to pause this video and have a go at finding the missing angles. And the answers to the following, please use a red pen to mark. And finally, we're just going to go through this example. Please make sure that you've copied this example as accurately as you can. But this is quite a good question that sometimes comes up in GCSE questions. So a triangle in a square. So you've got a triangle and it's inside another shape. Now you'd call this a compound shape, because you've got two shapes put together. So it's told you find the value of x, and you'll notice that x is this value out here. Okay, now we should know hopefully from the properties of our triangle that this is an isosceles triangle due to our two dashes here. So that means that this angle here is equal to this angle here. So the first thing we're going to do is we're given that top angle, which is different, which is the only angle that's different in this triangle. So we're going to do 180 subtract 80, which gives us a value of 100. Okay, so now we know that these two angles together, added together, equal 100. But because they're equal, it's very easy to find the value of 1. We're going to do 100 divided by 2, which gives us a value of 50. So both these angles now, we know, has a value of 50. But we're not trying to find any of the angles inside our triangle. We're trying to find the angle outside, so this angle here. And the way we're going to find that is we're told, using this little diagram, that this whole angle here is 90 degrees, but it's been cut just there. So in order to find what's missing, we're going to do 90 degrees subtract this value here of 50, which will give us a value of 40 degrees. So x is equal to 40 degrees. Now, it's quite simple to work it out, but these sorts of questions can confuse you. So please make sure you are copying this out as accurately as you can, and jot down any notes that will help you in the future with these sorts of questions.